Welcome, Security Weekly Unlocked, folks. My name is Justin Kohler, and this is my presentation on more attack paths than Nakatomi Plaza on Christmas, or why Active Directory is a favorite target and how BloodHound can help. We're celebrating this, where this conference is being presented in December, so I chose my favorite holiday movie, which is Die Hard. So you'll notice some theming around that as I get through. So who am I? My name's Justin Kohler again. I'm the product director for BloodHound and BloodHound Enterprise at SpecterOps. What that means is basically we've seen a lot of Active Directory. So SpecterOps is known for adversary simulation, detection, and training services. We've done a considerable amount of research and open source tool development in Active Directory. Probably most popular of that specific focus of open source products that we've developed is BloodHound, which we released in 2016, and I'll definitely go further in depth here. And then we recently released a enterprise version of that here in July. So what are we here to cover today? So I wanted to cover a few different questions. So what are attack paths? This has been covered in the past for sure, but we find that it always helps to kind of relook at this information, or maybe you're new to this topic and want to learn more. How do those attack paths form within environments? How are there so many of them? So we'll get into why that is the case. And what can you do about it today using the open source tool? So who's this for? Again, maybe you've heard of BloodHound or attack paths, but that's really it. You want to know more. And maybe it's being talked about, and again, you kind of feel out of the loop. Maybe BloodHound was used in a penetration test internally, and you need kind of a more in-depth understanding of what that tool did during that test or what it enabled. Maybe you've used BloodHound, but you were quickly overwhelmed by the initial results that you saw when you ran back the tool. Or you just have really good taste in holiday movies and appreciate Die Hard as much as I do. So bottom line up front for the executives, if you take nothing else away from this talk, you can just walk away with the information on this slide. Active Directory is incredibly powerful, and it's also incredibly complex. It has an extreme lack of visibility that can create millions, and I don't use that number hyperbolically, millions of attack paths, and we'll again get into why that is here in a bit. Your pen testers and probably some actual adversaries are abusing these every year. In some cases, even the same path year over year. BloodHound can be used defensively and be used as part of a defensive program. We've seen several organizations do this, and we have some takeaways and some good pragmatic steps to help you if you're interested in doing so, and as well as some pitfalls to avoid when you do that. So let's start out. What are attack paths? So we're going to make this a little bit more real. Let's start out with just a breach narrative or an incident narrative. So I'm not going to read this verbatim, but what you should take away is an adversary was able to get to a low privileged user, execute certain steps along their route, escalate privilege, and move laterally, eventually gaining access to a high privileged account in the domain admins group. It's important to know that each of these steps were executed in Active Directory. Now we string those together and we view those as what we call an identity attack path. Identity attack path is a term that's been around for quite some time, and we'll break it down here. So that same breach narrative in a path form starts with David, who's the user that was initially phished. David was a member of the help desk group. That group was a member of another group. This is what we call group nesting, or when a group is part of another group. It ends up, in most cases, giving way more privilege to David than originally intended. Well, that group has local administrator rights over a machine, which allows them to execute certain actions and execute code on that machine. That machine has another user logged in, a service account, and it's fairly trivial to carve that either the credentials out of memory or reuse the token. You can have privileged access management tools in place, and it's still possible to do this. So it's not a panacea. It's fairly trivial to abuse this. That service account happens to have the add member privilege over the domain admins group. So again, we went from a low privileged user to a high privileged user by executing these steps. And again, just for kind of restating the obvious here, but no direct connection exists between David and domain admins. That path was used to create that connection. So BloodHound is released in 2016 by Andy Robbins, Rohan Berserker, and Will Schrader. We released it at DEF CON and B-Sides back in, again, 2016. Penetration testers were able to quickly explore attack paths. So these attack paths are tradecraft that they used to execute all the time, but it used previously was done in Excel. Threw all that in a graph database and just made it much faster and easier. Defenders started using it to gain an understanding of those paths and start to mitigate those internally. And admins were able to visualize privileges for the first time. Again, we'll show you here in a second what admins are used to dealing with. BloodHound just made that much easier. BloodHound currently tracks around 6 object types and 22 different attack primitives, which is a different kind of word for an abusable relationship in Active Directory, or ways to take advantage of objects in Active Directory. So what are the data sources that BloodHound uses? So start first with the domain structure data. This comes from the domain controller, and it contains basically the structure of Active Directory: users, computers, organization units, group policy, yada, 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 the overall structure of what the directory looks like. There's also some critical information that we pull from endpoints. So the first one is local group information. So things like what are the memberships of the local administrators group on a random computer or a random server, remote desktop users, PowerShell remote, and so on and so forth. While you can manipulate the membership of these groups from the domain level through group policy, you can also manipulate those domain memberships by any endpoint management tool, or a user can manipulate them directly. A user can insert a random user or group into these groups, and that's never reflected at the domain controller level, hence the need to reach out to the endpoints. User session information is also extremely valuable and comes from the endpoints. Where are users logging in? Where are service accounts being used? Where can our adversaries carve those out of memory and replay those? So looking at that attack path that we looked at earlier, here is how those data structures play into that path. So we get all the objects again from the domain controller. We get a certain amount of those relationships again, also from the domain controller. We create this relationship by local group data and this last relationship by the session information. So BloodHound is released, and over the years, it's been recommended that you run it internally. There's one example here from the DHS where they recommend it. Another example from PricewaterhouseCoopers, where they also recommend it to map kind of the potential spread of ransomware within your environment by taking advantage of Active Directory. So let's say you start to run this. Well, this is a very small lab environment that this has been run in. So this is around 40 objects, I think, total. This is what it looks like when you roll an actual environment. Much, much more confusing. A lot of results can kind of be overwhelming. Where do you start, right? So let's look at, before we get into how do we start, let's look at how do they form. How are these being created in the environment? The first thing to acknowledge is risky relationships are invisible to Active Directory administrators. I'll show you what that looks like here in a second, but it's not like they're asleep at the job. They are doing a ton of work. They are experts in what they do. They care about security, but using the default tools within Microsoft and Active Directory, it's pretty impossible to understand where objects are gaining privilege and how to audit those. I'm going to show you exactly what that looks like by showing you the management interface for Active Directory, or ADOC. I'm going to show a video here. I'm going to swap screens. And we'll go ahead and play. So the first thing that we're going to do is pull up ADUC, or Active Directory Users and Computers, which of course here is called DSA, because why wouldn't it be called ADUC, which is what everybody else calls it. So let's start with, we want to understand the abusable privileges or areas of concern against a particular user. We'll start with a member of the domain admins group. So we'll start by going to the users area of ADUC, and we will first make sure that we have advanced feature set so that we can view this. And we'll also locate the domain admins group. So, okay, there it is. We'll right click here and select properties and go to members. And now we see all the members of the domain admins group. Awesome. So while we're listing out all the members, we kind of want to focus on a specific one and audit the privileges against that. So we're going to focus on that David McGuire user here. So we'll go over to users and we'll find David McGuire's account, and we will right click again and hit properties. And we, again, what we're trying to do here is understand the abusable privileges into a domain admin. So we'll go to security, and already we've screwed up. And that's because domain admin users have an attribute count of an attribute called admin count equals 1. This gets set when a user belongs to a certain type of group, and the SD process will analyze who belongs to those groups and copy the security descriptor from a different object in Active Directory and paste it back onto this object here. So we actually need to go to that object and look at the security of that object instead. So we'll cancel out of this. That object is in the system container and is the admin SD holder object. So we will again right click and select properties. We'll click on security and we'll click on advanced. And now we have all of the access control entries, or ACEs, on the admin SD holder object. Now we need to understand if any of these entries are abusable. So we'll pick a specific one to focus. We'll see that authenticated users with special access. What does that mean? Well, we have to click edit here to really understand that. And we're presented with a gigantic list. Are any of these rights abusable? You as a security pro or an admin need to understand that, which ones of these can or cannot be abused. There's quite a lot here to go through. Unfortunately, sometimes this interface doesn't even show what has been checked, which means you need to use something lower level like PowerShell and the ADSI to look at the actual raw security descriptor, which then you're looking into SDDL formats, and you'll need to be able to translate that so you know what the actual privilege is. So difficult, to say the least. So let's take a different example. That was the authenticated users with special. What if we had a custom group that had privilege over a user? We're going to take a completely different example. We're going to look at a different user. So we're going to navigate over to our user tab. And we're going to look at the Jeff McJunkin user account. We're going to go to properties. And again, go to that security tab and advanced. And we can see down here that the help desk users Washington group has full control over Jeff's account. Well, security group delegation tells us that members of the group will have the same rights that security group has. So we need to understand who's a member of that group, who can control Jeff McJunkin's account. So we need to go over to the help desk users Washington group to understand who's a member there. So we'll go to members, and oh, we find another group. So this is again an example of nested groups. So we have to actually go to the help desk users Seattle group to understand that. So we'll go to help desk users Seattle, we'll go to members, and we see my account, Justin K. So Justin K, through security group delegation, has control over Jeff McJunkin through this nested group. But we're not done there. What about other attack paths? Like Help Desk Users Washington. Well, that has control of Jeff, but who can control Help Desk Users Washington? So again, we're looking at all the access control entries on the Help Desk User Washington group. If we did it here, you're right, we have to also do it on the Help Desk User Seattle group. So we have to go again to all the access control entries here. And if that wasn't enough, yes, we have to also check my account, so the Justin K account. So we have to go through the same process and understand all of these different ACEs to understand who can control Jeff's account. We see here that there's an account unknown that has read-write privileges. That kind of seems scary. We see another authenticated users with special. What does that mean? Don't know, so we'll edit it. And again, get presented with this gigantic list of things that we have to understand. And so this process is understandably difficult and opaque. Hopefully this gives you a little bit of understanding how difficult it is to understand the permissions on these objects. But now what about group policy that applies to all of these things? Well, we won't get into that whole rat's nest. Just to suffice it to say, it is equally confusing. I'll flip back over to my presentation here. So you can kind of see the lopsided capabilities that are held by the admins versus what's held by, penetration testers, some folks on the defensive team that are running BloodHound today. So whereas we're presented with a list on one side, BloodHound graphs out these relationships and very quickly is depicting what is abusable or not. It's important to note that Active Directory is 22 years old. To put that in some context, that's between Die Hard 3 and Die Hard 4. We'll go ahead and concrete the fact that Die Hard 1 was the only true Die Hard. But 20 plus years of that opaque nature of Active Directory privileges has built up a ton of technical misconfiguration debt. So we've seen numerous examples. There's all types of examples that you can find online as well. Horror stories from, everyone principal having full control over the domain head object. And again, nobody intends for this to happen. This isn't like an admin falling asleep at the wheel or saying this configuration needs to be put in place. This doesn't happen on purpose. So this is another example from another organization, had 733,415 administrators for a computer. That's not by design. That's because security group nesting and the opaque nature of privileges in Active Directory ends up creating these paths. It's easy to pick on Active Directory, but that same underlying technology, which has its good and bad faults, has allowed businesses to build upon it and build repeatable processes on it, build technology that has powered their organizations for years. I mean, that is a great testament to the stability of the system. Improvements have been made to Active Directory. I mean, Lapse is a great example, absolutely awesome feature that was put in a couple of years ago. It's also important to understand that it's not going anywhere anytime soon. I imagine it's going to still be around before I get out of security. There are businesses that have built critical business functions on Active Directory, and while they may move to hybrid environments, maybe move to cloud environments, other directory services, there will always, we think, be some portion of this that will rely on Active Directory. It's not a panacea to go in another directory services and say, okay, that'll make it all better. It's also not unique. So easy to pick on Active Directory, but Active Directory is used by 90+% of all enterprises. But it's not unique. Any directory services, Azure, AWS IAM, Okta, you name it, you can create configurations that are opaque at the admin level, as simple as nested groupings. A group belongs to another group that ends up granting more privilege to that end user than originally intended. So it's not unique here. Every system has its faults. So let's get into why are there so many? So the best example, or the best way to explain this, is graph theory is working against you here. That's why there are so many paths and environments. So there's an example here from the 7 Bridges of Königsberg. It's an awesome read if you have the time, but it kind of formulated the beginnings of graph theory. But the end result is organizations with like 10,000 endpoints can have millions of paths. And I mentioned earlier that I don't use that number hyperbolically. That's real. We've calculated it out. It's pretty staggering. This is awesome for penetration testers, but it's really horrible for defenders and administrators if you don't know how to look at it, or if you don't know how to action it. The way we like to think about why this is think about a map, right? So John McClane, when he went to Nakatomi Plaza, came from New York down to LA. And he had a few different routes. Now, he took a plane, but let's say he drove. He had a few different routes that he could take from New York to LA, and he would probably choose the fastest route. But reverse this, say that you were in Nakatomi Plaza and you were trying to prevent John McClane from arriving. Well, how do you do that? Not only do you have to understand these 3 different routes, but you have to understand every route using every single road across the country. I mean, he could go through Austin and then go through Los Angeles. So it's a staggering problem on the defensive side. And you can kind of understand how these connections can sprawl and create massive attack paths in the environment. And it continues to grow every day, unfortunately. So new users, groups, and computers are stood up daily. New applications and service accounts. Login activity from every user changes every day, and thus changes the attack picture. And if that wasn't enough, we have hybrid environments and other things to now account for. And how does that extend our attack path picture? And this can get really messy fast. There's actually a fun subreddit called BloodHound Art. Not super active, but these are some entertaining examples. But this is what can happen in a real environment. There's just massive amounts of connections that can present themselves. So, okay, significantly alarmed. What can you do about it? First, you have to take action internally. So start your own attack path management program. Use open source BloodHound and run it internally. The benefits, we've seen this many times in organizations. They get out of reactive whack-a-mole operations. So they're not reacting to a single pen test that might be presented on a single attack path that might be presented on a penetration test outbrief. Not only is that kind of jarring and it gets into reactive operations, but it's also might not be the most effective route to take. So let's say, for example, that in that map analogy from New York to LA, that a penetration tester said, hey, we took this path from New York to LA, so fix that path. Well, you can just go and take a different route from New York to LA, even if we fixed it. Now, obviously fixing it is better than nothing, but is that actually the best use of our time? Well, unless you're running this internally and have the overall picture before an outbrief like this, you might be caught off guard and might be spinning your wheels. This also establishes common understanding across teams. So it's not just a security issue, it's an Active Directory issue, or it's an IAM issue. By starting up a proactive program internally, you're able to establish that understanding. So it's not, again, not surprising, not getting into that outbrief and presenting a finding and putting teams on the defensive. Why did this happen? And, oh, are you bad at your job? No, you can understand what paths are available, what those relationships create, and have a better kind of go forward strategy. You can also simulate future changes. So let's say I want to make this change in Active Directory. I want to remove this user, remove this privilege. What would that do to the attack picture? You can do that. Most importantly, you can make tangible and measurable progress. So again, proactive program, not reactive. You can understand where your current state is today and make steps to improve that. So 3 steps or 3 call it pitfalls and kind of areas for improvement that we've seen for organizations that are running this internally. First, be a team player. Don't be these guys. Coordinate internally first. So That involves the Active Directory team. That can involve the Identity and Access Management team. What you don't want to do is download BloodHound, run it across your environment, and then dunk on your other teams there and say, "Hey, I found all this stuff. Fix it." You're not going to go anywhere fast with that kind of approach. You need to take the time to educate, right? And don't pander. These are professionals in these teams, but then again, might not be aware that those privileges that are being set are creating these connections that adversaries can abuse. So they can also fill in some information, like what are those privileges actually used for? So it can be a really good kind of co-education opportunity. And then establish objectives. Don't just say, "Hey, we're going to find the paths," but what are the realistic objectives that we can execute with this program? And make sure everybody's on board with that. Not just a security objective, but this should increase availability for Active Directory teams. This should decrease churn by not getting into reactive operations. Number 2 is start with quantifying attack path risk wherever possible. What I mean by this is don't say this path is bad. Like, there are paths. Paths are bad, but not all paths are created equal. You can quantify them. You can start with the largest concentration of risk. What we recommend first is choose measurable attack paths. So I've got 2 really good examples here, and there's an article where we shared a few of these, and the link here is below. But large default groups with execution rights. So this would be examples where, like, the everyone principle or the authenticated users principle or the domain users principle, basically everybody more or less in our environment is in one of those 3 groups. Anywhere where those have execution rights, or maybe where those are added to a local admins group, creates a massive beachhead within the organization where everybody can launch an attack from. So let's say that everyone has the local administrator right over a bespoke machine. Well, all it takes is one random user to log into that machine, or a service account, or, heaven forbid, a privileged user logs in there. Everyone can launch that attack and then move again laterally and escalate privilege within the environment. So anywhere where you can say that, hey, nearly 100% of our users can execute this specific path by focusing on this specific relationship, it kind of quantifies what the risk is here. So it's not just a path that can be used, it's a path that is used by a wide range of our organization. The other one that's really helpful is privileged Kerberoastable users. So it's trivial for anybody to launch a Kerberoast attack, but you want to make sure, like, not all Kerberoastable users are created equal. So which Kerberoastable users have the most privilege in the environment? So we share in that article how to measure that. And so you can start first with the most risky Kerberoastable users. In other words, if somebody was to Kerberoast one of our users, are they an administrator? So how much rights would that gain them? And so again, we show how to do that in that article. But those are helpful ways. Instead of just starting with a bad attack path, you can say, this attack path is X bad, and here's why. And then finally, build a repeatable process. 20 years of misconfigurations aren't going away in a month. It's helpful to understand that this is a marathon, not a race. This is going to go away quickly. You need to develop a repeatable process that is sustainable and consistent. So when we talk about sustainable cadence, what we mean by that is we recommend analyzing monthly. Decide on 3 attack path categories per cycle, meaning per quarter or per month, that you're going to address. So let's say anywhere where large default groups have privileges. Well, we're going to report on that, and we're going to report on that quarterly. So we can say the change from Q1 to Q2, we had 6 entries of that issue, and now we are down to 2. We can show measurable results, and we can also comment on what the effect of that was in our environment by doing so. So thank you for your time. Again, I hope you enjoy the best holiday movie ever created as much as I can. The GitHub link for downloading the open source version of BloodHound is there, and you're welcome to contact me directly if you have any questions. And thank you again for your time.